Alright, so in this discussion 1 review, I want to start by touching on dimensional analysis, or unit conversion by using dimensional analysis. And this will be a really helpful tool that you guys will use throughout, undergrad and even in your careers, especially if they're STEM in nature. So, dimensional analysis, let me just write it out really quick. Dimensional analysis. So the goal of dimensional analysis, like I said, is to convert from units. And in this example, we're going to be working back and forth between miles, feet, meters, and leagues, which is a variable I've not heard of. So dimensional analysis has a really common setup where essentially you want to cancel out units by writing them either in the numerator or denominator of a fraction. So let's put that to paper by this example here. So if we want to convert from miles to feet, I can reference the key and see that for every 1 mile I've also traveled 5,280 feet. And we can set up a conversion like this. So 8 miles, and I want to set up another parentheses right next to it to multiply. Now, the second parentheses you can think of as your ratio between the two variables, or your conversion parentheses. So if I want to cancel out miles, I have miles up top here because you can think of this as miles over 1. So I want miles in the denominator here and feet up top in the numerator. Now I'm going to ask myself, how many feet are in a mile? And the answer is 5,280, and that aligns with our key. So if there's 5,280 feet in a mile, I am now ready to calculate and get the final unit, because here miles up top cancels with miles down below, and I'm just left with feet as my final variable. So if I type into my calculator 5,280 times 8, I'm left with 42,240 feet. Let's try another example. Now, let's look down here. We have 1 square meter, which we can represent like this, equals how many square feet? Now notice, these are units describing area. We have meters squared and feet squared. The first example we did was a length, or a distance. You could graph it in 1 dimension. So when we do dimensional analysis for this type of problem, we'll start by setting up our initial variable. Now when we go to write the second parentheses, you actually want to pretend that the squared is gone when you're doing your ratio. So if I have meters up top here, I want to put meters down below, not meters squared, and the same thing with feet. Now I know there are 3.281 feet per 1 meter, and now what I'm going to do is square this entire second parentheses. And the reason why we do this, and we don't just put the squares inside of the parentheses, is because we can't say that 1 meter squared equals 3.281 feet squared. That will not work. Let's take a look why that won't work. So this might not be exactly drawn to scale, but if I have, 1 foot, and I also have 1 meter, which is a little bit longer than a foot, and then I square this unit, so I have now 1 foot squared, we'd represent this as an area like this. And I could do the same thing with a meter, and now we have a square meter. So what we find is that if I'm mapping out, well, how many square feet fit in a square meter, or essentially saying how many a square foot is equal to how many square meters, we can fit a lot more square feet than 3.281. And what that means is that this, again, does not work. So that's why we're putting a superscript and attaching it to the second parentheses. So let's see what this equals. So 1 meter squared, and that's essentially saying 3.281 feet over 1 meter times 3.281 feet over a meter. So what we did was we took that square and we spread that out. And now we're left with 1 times 3.281 times 3.281, and we have 10.76. So let's decide our units now. What are we left with? Well, we have meters squared up top here, meters and meters down below, and that will give us meters squared when we multiply them. So they cancel out, and we're left with feet times feet, so now we have our desired variable, feet squared. All right, let's go. I'm going to jump to the bottom of this discussion sheet. Oh, I have all my old writing. Let me get rid of that real quick. So these types of problems are a little bit more complicated because we're introduced to units of 10, or the labels that are associated with different units of 10. So let's take a look at this problem here. We're going from miles to now megafeet. So we have to take into account what the mega is. So let's refer to our new chart. We see that mega is 10 to the 6th, or the same thing as a million. So we would say that 1 megafoot is equal to 10 to the 6th feet. That's how to interpret what this chart is giving us. So let's take that into account when we do our dimensional analysis parentheses. So just like the other ones, we're going to start with our unit of miles, our first unit, and let's convert from miles to feet, and then from feet to megafeet. So miles to feet, let's do that. Well, miles is up top here in our ratio parentheses. We want miles to be on the bottom to cancel out, and we have feet up top. And again, we'll use the 5,280 feet to 1 mile conversion. So that gives us miles canceling with miles, feet remain. Let's see how many feet we have left. So 24,901 multiplied by 5,280, and we get quite the number. We have 131,477,280 feet. So now we want to go from feet to megafeet. So let's set up another conversion where we have feet up top here, so we want feet on the bottom here. And let's put mega feet here. So going back to what we said with our conversion, 1 megafoot is the same thing as 10 to the 6th feet. So what we're doing is we're taking this number in feet and dividing it by a pretty large number. So we'd expect our final answer to be a lot smaller. So dividing by a really big number, 10 to the 6th, is the same thing as moving the decimal 6 places to the left. 4, 5, 6. And we get a new answer of 131.74 megafeet.